So in this video, we are going to do an introductory into functions. So a simple way of thinking of a function is through something called a mapping diagram. So imagine there's a set E and the inputs is 1, 2, 3, 4. And now there's a corresponding set B. And let's just say, for simplicity's sake, some function denoted by f of x. We're not concerned what the function is, just to introduce the concept of mapping input values to a corresponding output value. Let's say we get 1, here we get 4, here we get 9, and here we get 16. Now, the mapping from one set to another, or the inputting of one value into the function and getting a corresponding output, that is one way to think of a function. This function, to be precise, is something called a one-to-one function, meaning one input corresponds to one output. So we call this a one-to-one function. One-to-one function. Now, another way to think of a function is a function which is denoted commonly by f of x is written in terms of a variable. Simply, the readers use x plus 1. So, a function is an expression or equation written in terms of a variable. So, next way to think of a function where we input values of the variable and get a corresponding output for the function for that variable value as shown here. So like if we input, let's use this input values here. So let's input f of 1 into this function. You would get 1 plus 1, which is 2. F of 2 into this function, we would get 2 plus 1, which is 3. Now f of 3 into this function, we would get 3 plus 1, which is 4. And similarly, f of 4, we would get 4 plus 1, which is 5. So to draw or to illustrate the mapping of the input values 1, 2, 3, 4, and the corresponding outputs denoted by set B, 2, 3, 4, 5, still a one-to-one function, meaning one input corresponds to one output. And the function in question here is x plus 1. So I would encourage to think simply of a function as where you input in a value and you get in a corresponding output. These diagrams here are known as mapping diagrams. Now, I use the set A as inputs and the set B as outputs, but the mathematical terms for the set of input values is actually the domain is just equivalent to input values, and the set of output values is known as the range slash the co-domain, which is just equivalent in layman terms or simpler terms, output values. So let's do a table to investigate input and output. This is the next version of illustrating the input with the range and the domain of a function. Sorry, the domain and the range of a function. So we have the x values, we have the y values. So say x is 1 again, 2, 3, 4, 5. And let's use the function this time. Y is equals to x minus 2. So when x is 1, we will get 1 minus 2, which is minus 1. When x is 2, we would get 2 minus 2, which is 0. When x is 3, we would get 3 minus 2, which is 1. When x is 4, we would get 4 minus 2, which is 2. And when x is 5, we would get 5 minus 2, which is 3. And these values obtained from this table could just be plotted. Let's make a sketch of this. So let me just erase some. Okay, run out of space, but I'm pretty sure I can squeeze this in right here. So minus 1 is our lowest y value, 0, 1, 2, 3. Our x ranges from 1, 2, 3, 4, 5. So when x is 1, y is minus 1. So the first point is here. When x is 2, y is 0. The point where the line cuts the x-axis is the solution of the equation. Or the solution of the equation. Now when x is 3, y is 1, we will get here. When x is 4, y is 2, we get here. Not drawn to scale, but with drawn to scale with a ruler, you get it exact. When x is 5, y is 3, that is here. So we draw our function from the table or from the mapping diagram. In the other video, some more properties of functions shall be discussed. If you like and enjoy the content, please like and subscribe, and look forward to seeing you guys in the other video.